Welcome to the unit Fabric Preparatory Process for Dyeing and Printing. In this unit, you will understand the fabric preparatory process for dyeing and printing process. This unit comprises of 3 modules and a final review section that invites you to reflect on what you have learned. By end of this unit, students will be able to outline the preparatory process involved in dyeing and printing process. Explain various operations in different department in processing house. Describe important pre-treatment process sequence for different types of fibers. Let us now look at the preparatory process involved in dyeing and printing. Various operations in different department in a processing house and the important pre-treatment process sequence for different types of fibers. This diagram shows the general preparatory process sequence carried out on grey cotton fabric. Singeing. Singeing is the process of removing protruding fibers from the surface of yarn or fabric by burning. Fuzzy and protruding fibers are removed by burning them off. It is important for the fabrics that are required a clear and smooth surface for printing. Singeing is usually performed on both sides of the fabric. This is done in a singeing machine. In singeing machine, a fabric is passed over open flame at very high speed, approximately 200 to 400 meters per minute to prevent scorching. Then it is passed through water or desizing bath to extinguish any sparks. Uneven singeing may lead unlevel dyeing. Therefore, the fabric is passed through singer flat in open width and under slight tension. The gas burner should be properly controlled and maintained, otherwise streaky dyeing may occur. After singeing, the fabric next it goes to desizing process. What is desizing? Desizing removes starch from the fabric and makes the fabric more absorbent. There are different types of desizing process normally carried out in processing industry. Let us discuss different types of desizing process. First, rot stripping. Rot stripping is the oldest and cheapest method because no chemical is used in this treatment. The rot stripping process consists of 3 steps. First, the fabric is soaked in warm water between 35 to 40 degrees Celsius, then passed through a padding mangle and squeezed. Second, the fabric is allowed to stand for 24 hours. After that, it is hot washed. During storage, bacterial growth takes place which helps effective removal starch materials. These are the steps for rot stripping. Step 1. Wetting and squeezing in a 3-bowl padding mangle. Step 2. Steeping of wet fabric in a storage tank. Step 3. Washing in rope washing machine. Rot stripping is the most economical and simplest process. However, it is time consuming, can result in unevenness in desizing and there is no control over the process. Acid stripping. In the acid stripping method, dilute hydrochloric acid or sulfuric acid or a mixture of both are used to hydrolyze the starch from the sized fabric. The fabric is steeped in 0.25 to 0.5 or 10 grams per liter of the acid, passed through padding mangle and kept for 6 hours. The temperature rises to 50 degrees Celsius. The starch present in the fabric is liquefied and is easily removed by washing. Since acid can attack cellulose, care has to be taken to avoid damaging the cotton. The fabric should be washed with hot water after desizing. Advantages and disadvantages of acid steeping. The acid steeping process is less time consuming than the rod steeping process. The main disadvantage is that there are no control over the process. Oxidative desizing. In this process, starch is oxidized. The commonly used oxidative desizing agents are hydrogen peroxide, sodium bromide, ammonium persulfate. Hydrogen peroxide of 1 to 2 volume concentration and caustic soda 7 to 15 grams per liter is prepared in a padder. The cloth is first impregnated at room temperature and steamed for 3 minutes. During this process, some degree of bleaching also takes place. Advantages and disadvantages of oxidative desizing. In this process, the time required for desizing is less and the process is continuous. Water and energy consumption is less. Combination with other preparatory process such as scouring and bleaching is also possible. Excellent and uniform removal of starch materials. The disadvantages are there may be possibilities of pentachlorophenol content in the desized fabric that may be harmful. It is also an expensive process. Enzymatic desizing. It is the most effective and widely used method. Enzymes are biocatalysts of organic origin which are produced by living organisms. Chemically, enzymes are proteins of high molecular weights. Amylases are the enzymes used in desizing. There are two categories, namely alpha amylase and beta amylases. These enzymes can be derived from sources like animal, pancreatic and vegetable, malt and bacterial. This table displays the enzymes and conditions for desizing. In this process, the fabric is passed slowly through a saturator, thoroughly impregnated with the desizing bath and then stored for 8 to 12 hours, usually in the rollers. The impregnating bath is prepared with the required amount of the enzyme, a wetting agent and a proper salt, sodium polysulfate or sodium chloride. After batching, the fabric is thoroughly washed with hot water. Scouring. Scouring is the process of removal of natural oil substances like waxes, fats and pectins as well as added impurities like lubricating oil, dust, dirt and residual starch in the cotton material. Reactions during scouring. Oils, waxes and free fatty acids are emulsified by the soaps. Pectins are converted into soluble salts. Proteins are degraded into simple soluble amino acids and mineral matters that can be dissolved. Dirt is removed and other added impurities are broken into soluble products. There are different methods normally being used for scouring the cotton material. Let us discuss about the conventional process of scouring, which we normally call it as a cure boiling. A cure is a cylindrical vessel capable of holding 250 to 500 kgs of fabric. It is provided with temperature, pressure gauge and safety valve. For cure boiling, a mixture of 5 to 10 grams per liter caustic soda solution, 1% sodium silicate, 1% soap along with wetting agent are used. The circulation of hot alkaline liquor through the fabric is carried out under pressure at 25 to 30 pounds per square inch and 130 to 135 degrees centigrade temperature for period of 6 to 12 hours depending on the type of fabric. In the atmospheric scouring process, that is called open curing, is at 95 to 98 degrees centigrade for a duration of 4 to 6 hours. This is followed by hot and cold washes to complete the process. Next, let us discuss with very commonly used method of scouring process. It is called J-box continuous scouring. In continuous machines, scouring can be carried out through a series of J-boxes for progressive desizing and scouring. The desized and washed fabric is padded with strong alkali solution 5 to 10 grams per liter sodium hydroxide or mixture of sodium hydroxide and sodium carbonate, emulsifying agent and wetting agent. After padding the saturated cloth, it enters into J box where it remains for 40 to 60 minutes in plated form at a temperature of about 100 degrees Celsius. The cloth before entering J box is rapidly preheated by means of steam in U-shaped heating tube. The internal surface of the entire J box is very smooth to avoid any friction in the moving cloth. Now we will discuss about bleaching process. It is one of the most important process for textile chemical processing. Bleaching is to remove the natural coloring matters and make the fabric in required whiteness with minimum damage to fibers and within the shortest possible time. The commonly used bleaching agents are sodium hypochlorite, sodium chlorite, sodium perborate and sodium percarbonate. Hydrogen peroxide is a universal bleaching agent. Textile fibers like cotton, silk, wool, polyester cotton blends are bleached with hydrogen peroxide. Types of bleaches. Generally, there are two kinds of bleaches carried out for fabric preparation. The first one is full bleach. It is done generally when highest degree of whiteness is required and going to be used as a white fabric for apparels or to be printed with white background. This is achieved by bleaching with hypochlorite followed by hydrogen peroxide bleach. There is another type of bleached fabric, it is called off bleached fabric. Off bleach is done for fabric meant for dyeing and printing where more absorbency is required than whiteness, and fabrics to be used for application of finishes after dyeing or printing process. This is generally done by bleaching with hypochlorite or hydrogen peroxide of adequate concentration. Next we will discuss about sodium hypochlorite bleaching. The yarn or cloth after scouring is thoroughly washed before bleaching and is squeezed or hydro extracted to remove excess water, as otherwise it would dilute the bleach liquor. It is called chemicking. In typical batch treatments of cotton fabric with sodium hypochlorite in gears, the bleaching bath is prepared as follows. Sodium hypochlorite 1 to 3 grams per liter of available chlorine. pH of the bath is to be maintained between 11 to 11.5. The temperature is maintained in between 30 to 40 degrees centigrade. The time duration is 45 minutes to 2 hours. Since the bleaching is done in alkaline medium, that is pH between 10 to 11, the alkali which is present in the material has to be neutralized with dilute mineral acid after bleaching. It is referred as souring. Advantages and disadvantages of sodium hypochlorite bleaching. Hypochlorite bleaching is a powerful and economical way of processing. It is free from the defects of bleaching powder. However, excessive chlorine may cause pollution. All protein impurities must be completely removed before bleaching, otherwise the fabric may turn yellowish. The residual chlorine must be removed. Anti-chlor treatment. To remove the residual chlorine, the fabric is to be washed with sodium thiosulfate, that is a chlorine destroyer, or hydrogen peroxide in weak solution. The chlorine will wash away. This treatment is called anti-chlor. Next, let us discuss about hydrogen peroxide bleaching process. In this case, bleaching bath is prepared as hydrogen peroxide 1.5 volume, sodium silicate 2 grams per liter, wetting agent or detergent when needed, the pH of the bath to be maintained in between 10.2 to 10.8. The temperature is to be maintained about 80 to 95 degree centigrade. Bleaching is carried out near or above boiling temperature under pressure for 1 hour or more. After bleaching, the fabric is thoroughly rinsed with slight amount of basic solution to avoid formulation of insoluble silicates. Advantages of bleaching with hydrogen peroxide. Hydrogen peroxide is a universal bleaching agent and it is used extensively for the bleaching of cotton materials, and also it can be used for wool, silk, polyester and other man-made fibers under a wide range of applications. It requires less manipulation of fabric and hence less labor, results in lesser loss in weight of fabric than that the hypochlorite bleaching, is more absorbent than hypochlorite bleached fabric and has no possibility of fabric yellowing. Continuous bleaching process, J-box. In this process, desizing, scouring and bleaching are combined together. These are very attractive option since savings in time, energy, labor etc. are possible. However, combined operations are not always sufficient for preparation of certain cotton fabric for dyeing and finishing. In this method, the fabric is padded with enzyme bath and then passed into a wet steam chamber at 96 to 100 degree centigrade temperature, where the desizing takes place in less than a minute. The fabric after impregnation is taken out and applied into J-box at 98 degree centigrade and allowed to remain there for 2 hours, during which period the alkali reacts with the impurities. The fabric is then rinsed and impregnated with 1% hydrogen peroxide at pH 10.5 using 1% sodium silicate as stabilizer and wetting agent. The cloth after impregnation is again heated to 90 to 95 degree centigrade and stored for an hour in J-box. It is then rinsed thoroughly. Biopolishing is one of the value added process during preparatory process. It is a process of surface modification of cellulosic fabrics like cotton, linen to improve their cleaner surface, cooler feel, brighter luminosity of color, softer feel, more resistance to pilling using cellulase enzyme is called biopolishing. It can be applied to woven and knitted cellulosic fabric like cotton, linen, rayon and their blends. The elimination of microfibrils of the cotton fibers is obtained by controlled hydrolysis of cellulose. Biopolishing may be carried out at any time during wet processing. It is most conveniently performed after bleaching. Optical whitening or fluorescent whitening treatment. This process also value added process for cotton preparatory process. The purpose is to obtain extraordinary brilliant whiteness to cotton materials. Optical brightness acts as fluorescent dyes and they are colorless. They absorb light near to ultraviolet region below 400 nanometer and re-emit the light in the violet blue visible region. Near white bleached cloth possesses a yellowness caused by absorption in the blue region. When fluorescent whitening agent is applied, the blue fluorescence complements the yellowness and adds bluish hue to the fabrics, which the eye appreciates as brilliant white. Application of optical brightness. Optical brightness are classified as direct, disperse and cationic types. The direct brightening agents are mainly used for the brightening of cotton, linen, viscose and nylon materials. The acid fluorescent brightening agents serve mainly for the brightening of silk and wool fabrics. The disperse fluorescent brightening agents are used primarily for polyester, acetate and acrylic materials. Mercerization. Mercerization is one of the most important preparatory process for cotton materials. Mercerization is defined as the treatment of cotton fabrics or yarns with a cold concentrated solution of sodium hydroxide solution for 1 minute or less. During the process of mercerization, the following action will take place: the morphological structure of cotton fibers. The cotton fiber swells, untwist and their bean shaped cross section changes into round form. The image here shows a cross section before mercerization. Mercerization improves the following properties. It modifies the internal reorientation of cellulose structure, increases the strength by 15 to 25%, improves elasticity and dimensional stability, enhances luster and feel, improves absorbency of water, dyes and other finishing chemicals, increases the uniformity of dyeing, improves the color yield by increasing the dye affinity, resulting in enhanced color fastness and saving in cost of dye stuffs. Mercerization process. The fabric is padded with about 20 to 25% sodium hydroxide solution containing a wetting agent. It is then passed over several cans to allow a dwelling time of approximately 1 minute. During this time, sodium hydroxide will penetrate the fibers and react with them. At this stage, the tension is applied lengthwise. The fabric is then placed on a stenter frame and it is pulled to its desired dimension. Tension is applied in both warp and weft directions. While on the stenter frame, the fabric is washed by spraying water until the concentration of sodium hydroxide is reduced to less than 1%. Then the fabric is washed by passing through several washers, one of which contains a diluted sulfuric acid or acetic acid. Next we will discuss about wool preparatory process. Preparation of wool fibers. Impurities present in wool fibers are animal fat, suint, that is a dried perspiration, dirt, mineral and vegetable matter. Wool scouring. The technique consists of passing wool fibers through a series of 4 long narrow bowls containing soap or non-ionic synthetic detergents and sodium carbonate at temperature of 40 to 50 degrees centigrade. You can see the table displays the details of the wool scouring process. Wool scouring process in the diagram, bowl 1 where scouring takes place, bowl 2 also scouring takes place, bowl 3 rinsing and bowl 4 again further rinsing. Raw wool scouring machine contains 4 bowls. Each bowl consists of a long trough provided with a false bottom. Soap and alkali are added to the first bowl. Detergent is added to the second bowl and third bowls and only water in the fourth bowl. Next we will discuss about another process of wool preparation, that is called carbonization. Carbonizing, in this case, cellulose material such as leaves, grass, seeds and vegetable fibers are removed. The wool is treated with a diluted solution of sulfuric acid, then dried. Cellulose materials decompose to form a fine black powders which can be easily dusted out. Next, we will discuss about wool bleaching. Two methods of bleaching are commonly used. the oxidation method using hydrogen peroxide, the reduction method employing sulfur dioxide, sodium bisulfite or sodium hydrosulfite. Sometimes the wool is bleached with peroxide followed by bleaching with sulfur dioxide. This is a method of peroxide bleaching under acidic condition. The bath is made up of 4 volume of hydrogen peroxide containing 0.25% formic acid and adjusted to pH 3 to 3.5 at room temperature. The scoured material is impregnated with the peroxide solution on a padding mangle and allowed to stand overnight. It is then washed. Silk preparatory process. Silk is a protein fiber made up of fiber forming protein called fibrin. The fiber forming protein is coated heavily with a gum protein called sericin, which gives a harsh and stiff feel and hides the rich luster and whiteness of the silk filament. The sericin gum has to be removed as the first preparatory process of silk before dyeing. A typical silk filament is composed of fibrin 75 to 80% and sericin 20 to 25%. Silk degumming process with synthetic detergents. Synthetic detergents are now being increasingly used in place of soap. Their main advantage is that they permit continuous processing of pieced goods and the time of treatment is shorter, about 40 minutes. In this method, the material is treated with 2.5 to 5 grams per liter detergent at pH 11.2 to 11.5 for 30 to 60 minutes at boiling temperature. Then rinsed thoroughly first with hot water and then with cold water. The drawback of this method is the soft feel is not always obtained. Treatment with some protein enzymes like trypsin or papain may dissolve the sericin gum. The treatment is time consuming and involves 3-step process. This treatment is longer than that with synthetic detergents. The 3-step process, which includes, in the first step, the material is first treated with 0.5 grams per liter soda ash, 0.5 grams per liter Glober salt, 3 grams per liter penetrating agent like Mercerization at boiling temperature for about 1 hour. The second step, it is then treated with 1 to 5 grams per liter sericin dissolving enzyme, that is trypsin or papain, 1 grams per liter soda ash, 2 grams per liter Glober salt at 45 degrees centigrade. Finally, in the last step, the above material is treated in the third bath with 0.5 grams per liter soda ash, 2 grams per liter sodium silicate, 2 grams per liter penetrating agent and 0.5 grams per liter Glober salt at boiling temperature for 1 hour. Silk bleaching. The process of bleaching silk consists of boiling the material with 1 to 2 volumes of hydrogen peroxide, concentration about 0.3 to 0.6% and 2 grams per liter sodium silicate for 2 hours, which is followed by a hot wash. As an alternate method, the amount of silicate can be reduced using a small portion of ammonia to bring the pH to 10. Here the mixture of 0.8 grams per liter ammonia and 1.5 grams per liter sodium silicate, the temperature is kept at 70 to 75 degrees and time duration of 5 to 6 hours. The silk is then soaked at 80 to 85 degrees centigrade and washed in hot and cold water. Polyester preparatory process. Pretreatments for polyester. Fabrics made of 100% polyester containing size materials, spin finishes, conning oil and tinting colors as major impurities and do not have any natural impurities. Desizing of polyester. Polyester fabric consists of only water soluble size materials such as polyvinyl alcohol etc., which can be removed by a treatment with a mild alkali such as polyvinyl carbonate up to 4 grams per liter detergent at 70 to 80 degrees centigrade for 1 hour. The fabric is then washed hot and cold water. Polyester scouring. 100% polyester fabric can be scoured using 1 to 5 grams per liter sodium carbonate and 1 to 5 grams per liter detergent at a temperature 60 to 70 degree Celsius for 60 to 90 minutes using a jet dyeing machine. Polyester bleaching. For full white fabrics, polyester can be treated with 1 to 5 grams per liter sodium chloride, 1 to 2 grams per liter sodium nitrate and 1 to 2 grams per liter formic acid 85% and pH about 4.5 at boiling temperature for 60 to 90 minutes. The fabrics are then washed with hot and cold water. Heat setting of synthetic fabrics. Heat setting or thermosetting is a heat treatment applied to fabrics made of thermoplastic fibers such as polyester or nylon to impart dimensional stability. Heat setting temperature are well above the glass transition temperature of fiber. Heat is applied by means of hot air, heated cans or steam. The treated fabric acquires dimensional stability, that is a memory to shape it was during the heat setting. It will resist shrinkage and creasing and will have the ability to maintain pleats present in the garment during heat setting treatment. In a typical heat setting of polyester, the fabric is placed on a stenter frame set to the desired final width. The temperature is maintained in the range of 190 to 215 degrees Celsius for 30 to 90 seconds. Heat setting affects the dyeability of fiber. Usually it decreases its dyeability and therefore when performed before dyeing, it is extremely important to apply heat setting uniformly. Uneven temperature in the oven may cause difference in the fabric from the selvage to selvage and from selvage to center, which will show later as uneven dyeing. You have come to the end of this unit. To summarize, in this unit, you have learnt about the preparatory process involved dyeing and printing process. You have also reviewed the operations in different departments in processing houses: cotton preparatory process, wool preparatory process, silk preparatory process and the polyester preparatory process. Finally, you have also examined the important pretreatment process sequence for different types of fibers. Thank you.